Hello everyone, welcome. I am Tracy, and today I'm going to work on a housing here. It's a protective sleeve housing for a PTO. And the welds on it have cracked. And I've made a base plate so that I can anchor it down. These holes have all been patternized, but there's a crack at each one of these welds. And I've ground down each side, and I'm just going to I'm going to bolt this down real tight so that when I do weld it, this flange doesn't tulip up. So let me see in there. You can see a hairline crack right there. There's one over here in this corner. I ground that one out. I ground down only 2 of them right now, so I'll weld them out and let it cool back down so it doesn't overheat. The welding is done with a 332 tungsten pure, and I ground it down a little bit of a point, but what I'm going to do is straight polarity. That is your TIG torch is on negative, and your ground is going to be on positive, so it's DC current. And I'm going to strike an arc on this copper right here and melt it until it leaves a little bit of a tip on the end of this, a ball tip. That ground hooked up the table, little arc through here. I wish this was a little thicker. See what happens. We have it on 100 amps. It put a tip to it, but it burnt. Put a slight tip to it, but it burnt that copper fast. It needs to be that hot just to get the little ball tip on the end of it. And the reason it's straight polarity is the arc force, the amount of current of force. There's only 30% of your force coming out of this tungsten, and 70% going into the ground. So it's going to heat this up fast. That's what's going on. But you're not going to overburn the tungsten. As you can see in this picture, the positive lead on the left-hand side of the corner, upper corner, the positive lead goes to the ground. That's 70% arc force. And the negative lead goes to the TIG torch. And I'll show you a picture of how I've hooked up the stinger to the TIG torch. All right, I have the stinger hooked up to the TIG torch block. And the negative lead is hooked up to the stinger whip so that makes it straight polarity. And the positive lead on the welding machine hooks up to the ground. It's just straight polarity, and that's how it's hooked up. Okay, I've got 2 tungstens, and I need to make 4 of the ball tips. So I'll speed this up a little bit and show you. I'll go through each one of them and make a ball tip on the end of it, so that I have, some extra ones in case I contaminate that tungsten and I need the newer, clean tungsten. All right, finished doing that. I got 4, this pure tungsten, I got 4 ball tips made. This copper piece here cooled down. That thing's junk. You get a thicker one. So now I got to take the leads and go back to AC. So it's coming off the welding machine, and I'm going to put the positive lead on the positive side of the high frequency box, and then the negative on the work side. And positive's hooked up to, coming off of the outlet side the same way. Positive lead goes to this. But at the welding machine, my machine, the 300 DLX, it has AC. So I'll go out there on the control arm and go to strictly AC. It's not. My amperage is controlled out there, a maximum. I can control, I can lower it and raise it, the AC current. And then I've got my fine-tune control right here, if I want to. Or I've got a foot pedal remote control. And that's used a lot. I'll hit it high when I strike the arc. Sometimes then I'll let off of it real quick, and then I'll step back down on it and I'll warm up that material. This isn't hooked all up yet. I got some switching to do right now, and then we'll get back to welding on this. So anyway, it's got it set up, and then it's got another control cable that you flip the remote control on, and then it signals to the machine when to rev up and power everything else in here. So I'm going to turn it on, lights on. If I would to leave this on local, that means this is where I'm going to control my amperage, but I'm going to go to remote, and that's going to be the foot pedal. And I start at 0, I activate it, you can hear it, it'll start jumping, or you can hear it clicking. You're going to see here I've grabbed a tube of its wax. You can buy it at any building supply, just about, Menards and Lowell's, but it helps the burrs or the debris or the metal fly away and doesn't get caught up inside this tool bit that I'm using to grind out the old weld that had a crack in it. The air tool that I'm using, it's a little bit slower. It's not a real fast speed. It's like a drill. And that bit that I'm using is an extreme heavy cut. There's probably more that's more extreme than this one, but there's like an 1/8 of an inch gap in between each little area that it cuts. And if you don't have that slower moving air tool, that thing's going to bounce on you and get way out of hand. But there's a certain way that I'm holding it also, because of the direction it turns, the air drill, and it helps keep it from bouncing back and forth as well. When I finish grinding, cleaning this old weld out, there'll be a separation in it between the piping and the flange. Then I'll use this cleaner. You see it in the upper left-hand corner there. It takes all that wax and any contaminants, that grease, it dissolves it and cleans it out. And then I'll blow it down with the air. And then I will bolt that flange to that plate so that when I weld on it, it won't tulip up, and I'll preheat it to a couple 100 degrees or more. I wound up turning the welding machine at the panel, on the front panel of the welding machine, to 225 amps AC, and the flange is thicker than the 1/4 inch that I was practicing on. And I preheated this material also just a little bit, about 200, 250 degrees. It needs more heat. I've only got a 332nd tungsten I'm using on it, and I'm wanting to put a small root bead in at first, and then when I'm done welding, finished welding, I'll let it cool back down before I unbolt it or start grinding anywhere else later. I finished welding in the root bead, and then I took the stainless steel brush and cleaned the weld again. Now I'm going to put a second pass on it, and it's the cap pass. So I'm going to start at the top and circle around clockwise from the top of the toe of the weld to the bottom, and then also add metal in and get it to flow. The bead needs to, finished bead needs to be more flat than convex or concave. The shielding gas that I'm using is 75-25. It's 75% helium, 25% argon. It does create a much hotter puddle. And everything's bolted down, of course, like I said, so that it doesn't allow it to tulip up. It's going to draw tremendously. And the flow on the meter is about 20 to 30. I don't want a lot, but I want enough to where it's going to shield that weld. And it has to be in an environment that there's no wind. Finished up welding, then the material's cooled down so it's easy to touch and take apart so that the flange doesn't want to continue to draw. And cleaned all the welds up. It's ready to go back on the equipment that it came from.